passion with programming and education and creates blog posts, records video courses, and other educational content focusing on security,
Hey John, can you come with me, please?
authentication, and more. Being a full-stack developer, he prefers working with Angular on the front end and flip-flops between Node.js and Go on the back end. His talk will cover an often overlooked but very important aspect of single-page applications, which is security.
All right, how are you guys doing today? Awesome. Well, welcome to the 14th annual SATURN conference. It seems that this conference has outlived a whole lot of JavaScript frameworks. And today we're going to talk about single-page applications, JavaScript frameworks that live entirely in the browser and how we can secure those frameworks. Now, before I get started, how many of you guys are front-end developers that currently work on single-page applications? A few. Okay. So how many of you guys know what single-page applications are or have heard of them? Okay, so most of you. So this talk, for those of you guys that are new to single-page applications, we're going to go over how they work, why they work the way they work, and also how to secure them. And for those of you guys who are already working with single-page applications, we're going to learn some new things when it comes to securing them. So with that said, let's get started. So my talk is titled, A Token Walks into a Spa. And I'll use this guy. So just a little bit about me. My name is Kukic, and I work as a developer evangelist for a company called Auth0. How many of you guys have heard of Auth0 before? Okay, awesome. So a couple of you. So for those of you guys that haven't, let's go back. So for those of you guys that haven't heard of Auth0 before, we are an identity as a service platform. So we basically take care of all of those pesky security, authentication, authorization use cases and make it really easy for developers to integrate it into their applications so they don't have to spend the time to do it. And if you guys want to follow me, at Kukic on Twitter. If you have any questions, we have a 90-minute session here, so my talk will be done way before that, so we'll have plenty of time to talk. But if you don't get to ask your question, please follow me, and I will be happy to follow up with you. And also, before we get started, since we do have kind of a smaller group here today, if you do have any questions, if I don't understand or explain anything to your understanding, feel free to stop me in the middle and just ask away, and we'll make it fun. And then one final question before I get started. How many of you guys came to this session because of the pitch earlier versus you had already planned on coming? Okay, sweet. All right, so let's get started. Single-page application security best practices. As you guys may know, single-page apps built with platforms like Angular, React, ViewJS, maybe even jQuery, live entirely in the browser. So when a user visits your app, visits your application, the entire code base gets downloaded into the browser. And this means that you can't have any secret keys, you can't have any API keys, and you can't really have any private data inside this application unless you want a malicious user to go into it and extract your API keys, extract any private data that you've hidden. Now, you can try minifying the data, you can try obfuscating it, you can do a couple of tricks to try to make the data hidden, but a malicious user with enough intent, with enough time, will be able to reverse engineer your app and get those keys out. So when it really comes to single-page application security best practices, we really don't have any, right? So we can have data in the browser that's private, that's secured. And that's the end of the talk. Just kidding. So before we get into the security SPA security best practices, let's kind of look at where we've traditionally come from and how we've built applications in the past and why those were secure. So in the traditional app infrastructure, you typically have a server that lives behind a firewall that has all of its code kind of in a private repository that's living on the server that end users don't have access to. So for the rest of this presentation, we'll use a hypothetical application called Avengers.com, because the Avengers just came out, and we'll try to be topical. Within our Avengers application, when a user comes to the application, they're going to come typically via a browser. So we'll use this red color for our browser because it's insecure. Everything on it is public. And since we're building a traditional app, our Avengers front-end application and our server live on the same domain, and everything just works. And then we have this separator, this firewall, that kind of separates the public area where everybody has access to everything from our server where we execute our logic, where we process the requests, render the pages, and all of that good stuff. So when a user comes to our Avengers application, they're really looking through a one-way mirror. They land in the browser, they go to avengers.com, and they make a request to our backend. Now, our backend is going to look at this request, it's going to process it, and say, hey, does this user have permission to see the page that they requested? So in this case, say the user came to the home page that doesn't require any specific authentication, doesn't require authorization. So what our server is going to do is it's just going to render the page server side, render all of the HTML, all of the CSS, all of the data, and it's going to send it back to the browser. And now, if the user were to log in or to request a protected resource, again, they're going to make a request to our backend. Our backend is going to process this request. It's going to say, hey, now, say we're trying to log the user in. We're going to check the user's credentials, make sure they are who they say they are, and then we're going to respond with, you're authenticated. Here is a session ID that we'll store in a cookie. And then for any subsequent request, we're going to look at that session ID, check it against the database, make sure that the user is still logged in, still has access. And then we're also, as we traditionally do, render the page server side, send it back to the browser. And that's the traditional app experience. And we've done this for 20, 30 plus years, and this works really well. It's tried, it's tested, battle tested, and generally secure. But we typically don't build applications like this anymore because we want to give our users a modern user experience so they're not refreshing the page every single time they try to access a resource. The rise of AJAX queries and single-page frameworks kind of spoiled us and allowed us to do a lot of really neat things within the browser, but it also opened up a whole lot of new issues. So if we look at the modern, and I'll use quote-unquote modern application infrastructure, now we still have a secured server on the back end. We still have this secure sandbox where we process all of our logic, where we decide which private data to send to the browser. But now we're no longer putting this application typically on the main domain. We might expose it via a URL like api.avengers.com, and this server, it no longer renders the UI. All it does is that it processes the requests that come in, and it returns a response based on the request. So it's not concerned with user experience, presentation, or anything like that. All it's concerned with is sending data back and forth. And now we have our presentation layer, our application layer on the front end, and this app might live on a domain such as app.avengers.com. So now our backend server, our logic, our application logic and our presentation logic are living on two different domains. So the first problem this presents is that we can no longer use cookies easily within the application. There are ways around it, but it's messy, it doesn't work really well. So the first problem we have is our logic layer and our presentation layer are on two different domains. And for the purposes of this talk, we'll use single-page applications as kind of like the general term, but it could be a Vue app, it could be an Angular app, it could be a React app, it could be your own JavaScript framework that you rolled up because you want it to be unique. And being the good modern developers that we are these days, we typically don't only design for a single application, a single front-end client. We might be thinking of a mobile app, such as an Avengers mobile app. We might also be thinking of building our, exposing our logic to an IoT device, such as a Google Home or Amazon Echo, so that we can have many more interactions and we can get more users across different devices. So with that said, now we have this much larger public realm where our front-end clients live, and we can assume that they're not secure. You can have a mobile application and try to put keys in it, but if you don't properly encrypt it, somebody can download like the Android APK, go into it, and get the keys out of it. If you're building an Angular app, everything lives in the browser, so any private data you store there again kind of can get stolen very easily. So we want to ensure all of our secrets, all of our private data are on the left-hand side, and they are secure. And ideally, we would want all three of these front-end applications to talk to our backend using the same protocol. So we might be using a RESTful API, we might be using like a GraphQL or a SOAP service to transmit requests to our backend and then to get responses in typically JSON format, but again, it might be XML, it might be a different language. So this is kind of what the modern application infrastructure looks like. We have a secured backend and we have a public front end, and we need a way for these front-end applications to talk to our backend service in a secure manner, because we don't want just anybody to be able to talk to our API, get the private data out of it. That would also open us up to a lot of different issues and a lot of different attack vectors and stuff like that. So how do we kind of secure our communications from this public front end to the private back end? And the answer to that is JSON Web Tokens. And for those of you guys that don't know what JSON Web Tokens are, let's do a very brief definition. So JSON Web Tokens are an open industry standard method for representing claims securely between two or more parties. Now, this definition doesn't really tell you too much about what JSON Web Tokens are, how they work, and when I first read it, I was kind of confused. And before I move on to the next slide, JSON Web Tokens, JWTs, and JOTs, I'm going to use these terms interchangeably. They all mean the same thing. But basically, if we look at JSON Web Tokens, or if we look at that definition, and then we look at what a JSON Web Token is, now we're even more confused, because now we have this jumbled up string of characters that nobody knows what it means. And when I was first learning about JSON Web Tokens, I kind of went the technical route. I read the RFC spec. I was trying to understand all the technical elements of it. And I kept hitting roadblock after roadblock after roadblock. So what I want to do is I actually want to kind of use an analogy for how token-based authentication works in the real world. And we'll kind of roll it back into our application infrastructure and how it works in relation to single-page applications talking to a secure backend. So token-based authentication in the real world. One of the reasons that we'd want to use JSON Web Tokens is, one, they are compact. So all the information, so they are compact and they're self-contained. So when it comes to JSON Web Tokens, all the information we need is stored within the token itself. So if we look at that traditional application infrastructure where we just set a session ID within our application, every single time we make a request for a new resource, we have to check that session ID against the database to see if it's still valid. And if it is, then we have to do a bunch of more database lookups to get the user information, to get their permissions, and then finally to go ahead and process the request. When it comes to JSON Web Tokens, we can put all of this information in the token itself. So once we verify that the token itself is valid, we can go ahead and just process the request without doing additional database lookups. And finally, tokens are secure because they are signed, and we can verify the integrity of the data within the token. Woo. So if we go back and look at the token-based authentication in the real world, the example that I'm going to use today is a driver's license. So the question that I want to answer is, how is a JSON Web Token like a driver's license? Now, everybody, I assume, has seen or owns a driver's license, so I think this is a fairly familiar and common thing that we all have, we all use, so hopefully we can make the analogy work. And the way we're going to do this is we're going to take the components of a JSON Web Token, we're going to roll them back into our driver's license and kind of see if it matches up. So the first part of a JSON Web Token is its header. And the header of the JSON Web Token really just tells you what you're working with. So let's put our driver's license on the left, we'll put our token on the right, And let's look at the header for a driver's license. Typically, the header of the driver's license is the fact that it is a driver's license. It's this little card that you hold. This particular driver's license even says on it that, hey, this is a driver's license, and it was issued by the state of New York. So that's really our driver's license header. It's just a few pieces of data that tells us what we're looking at. If we look at our JSON Web Token, the header is this first part in orange, starting with E, Y, J, H, blah, 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 ending at the first period. And this is just a base64 URL encoded string, so we can easily pass it via HTTP requests. But if we were to go and actually decode this string, what we would get back is a JSON object that has two properties. The first property being ALG, or algorithm, and the algorithm property simply tells us what hashing algorithm was used to sign and verify the integrity of the token. And in this case, I used HS256, and we'll get into these algorithms in just a little bit. The second property or attribute of our JSON object is its type. And here, it's JWT. And for most use cases, if you're working with JSON Web Tokens, this type property is always going to be JWT. It's kind of redundant, but it's there because in the future, we might have different types of tokens. So that's the header, not a whole lot to it. The next part of the JSON Web Token is its payload. And the payload is really the most important part of the token because it is what contains the data that you're going to use within your backend applications. And it is the data that you want to transmit securely between the front end and the backend. So once again, let's put our driver's license on the left, our JSON Web Token on the right. And if we look at the payload of the driver's license, it's just all of the other data that's on the driver's license itself. So we have the picture of the user, we have their name, their address, their demographics, such as their date of birth, eye color, weight, height, data like that. And then finally, perhaps the most important is their set of restrictions. So what type of vehicles can they operate with this specific license? If we look at our JSON Web Token example, the payload is the part in black, again starting with EYJZ, blah, 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 and ending at the second period. And again, this is also a base64 URL encoded string, and if we were to decode it, we would again get back a JSON object that has a couple of different properties. And this particular token has 4 properties. One of them is sub or subject, which is essentially the user ID, the user identifier, a given name and family name that tells us who the user is. And then finally, this admin property, which is set to true, telling us that this user is an admin, so they should have some elevated permissions. Now, here I just have 4 different payloads, but when it comes to your JSON Web Token, you can have as many payloads, as many claims as you want. The more you have, the bigger your token will be, but you're not really limited to the type of data you can put in here. As long as it's a valid JSON object, you can put it in here. Now, when it comes to the payload, there are also a couple of different types of claims we can make within the token itself. So let's kind of take a look at that next. There are really 3 types of claims. There are reserved or registered, public claims, and then finally private claims. And I want to go a little bit more in depth into each one of these. So we'll start with reserved. The reserved claims are really registered, and they're kind of defined by the RFC spec that created the JSON Web Token standard. And there's only a small handful of these, maybe 10 to 12. And these claims are really short, so they all have 3-letter acronyms. So for example, the EXP claim stands for the expiration time of the claim, or the expiration time of the token. So after this date has passed, the token will no longer be valid. It'll, you could throw it away. The IAT claim stands for the issued at claim, which tells you when this token was generated, when it was created. The ISS claim stands for issuer, and this is the party that issued the JSON Web Token, and we'll get to that in just a little bit. And then finally, we have the audience claim, or AUD, and this claim stands for who the token is intended for. So there are 6 or 7 other different claims, but these are typically the most common ones you'll use in your JSON Web Token implementation if you decide to implement it. Next, we have public claims. And public claims, they're registered with the IANA, and a lot of these claims are actually registered by the OpenID Foundation. And with these claims, what they're really meant for is API interoperability. So these claims kind of help you, if you plan on exposing your application to different clients, different applications, to kind of have a standard set of data attributes that you want to pass back and forth. So claims such as using given name instead of first name, or the address claim to kind of have a standardized way of representing the user's address are good examples. And updated at is another one that's registered, so when the data was last updated. And then this last one, CNF, which stands for confirmation. So these are just a couple of different examples of public claims that you can use within your JSON Web Tokens. And again, a lot of these are optional and you don't have to use them in this specific manner. But if you are building an application that you foresee talking to different types of applications, different APIs, you may want to use them. And again, the list of public claims is really, really short, maybe 50 to 60 different ones.
Are the reserved ones required?
They're not required either. So, good practice to have them, but not required. They're all kind of optional. And then finally, we have private claims. And when it comes to private claims, these claims are specific to your business domain, to your application domain, and should really only mean something to your application or API. So here you might have a property like I did that says admin, and it's like a Boolean true or false that tells you if this user is an admin or not. You might have a property, if you didn't want to do a all-encompassing admin or not admin, you might have a roles property which passes in an array, and it tells you what types of things the user can do in your API, and same thing with permissions. So these are really up to you. You can name them whatever you want. You can put data in them however you see fit, but they are private claims and they only mean something to you.
Question?
Sure.
Are there any provisions for preventing name collision on private?
So there are not, and that's why, if you kind of follow the IANA and the RFC guidelines for the 60 or so registered claims, you'll kind of prevent collisions that way. But when it comes to private claims, it's really, up to you to kind of figure out which apps you might be interfacing with and to make sure that you don't have the collisions. And I think I went too far back. So finally, we get to the signature of the JSON Web Token. And what the signature is really the mechanism that verifies the integrity of the token. And I'll explain why that's important in just a little bit. So let's put the driver's license and token side by side up again. And the signature for our driver's license is typically a UV light hologram or an embedded chip within the driver's license. So when you go to the DMV, you fill out all that paperwork, you spend 8 hours sitting and waiting. Once they issue you a valid driver's license, it's going to have a little hologram on there that other parties that need to verify that this is a valid driver's license will be able to kind of reference. And if the hologram is correct, if it lines up properly, they can assume that this is a legitimate driver's license. Otherwise, they might think it's a fake. And when it comes to the signature of our JSON Web Token, that's the part in green starting with the UL and ending with the I at the end. And the way we get the signature is we take the header of the JSON Web Token, base64 encoded, and the payload, base64 encoded, put them together, and then we run it through a hashing algorithm. And in this case, I'm using HMAC SHA-256. So I take my header, I take my payload, and with this algorithm, I use a string-based key or a string-based password to sign the token. So this algorithm is going to run, and it's going to generate that signature UL, RN, blah, 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 blah. And that's going to be our JSON Web Token. Now, since I have this token, and when I pass it to the backend of my application, once I log in, my server is going to issue the token, and I'm going to send it to the backend. The backend, in this case, is going to have the key Loki sucks, and it's going to see, it's going to look for any of the incoming JSON Web Tokens, and it's going to see if they're signed with that particular password or key. And if they are, it can assume that the JSON Web Token is valid. it came from a trusted source, it was signed with the correct password. And this is important because the header and the payload of the JSON Web Token are base64 URL encoded. They're not encrypted. So anybody that gets a hold of this token can easily see the header and the payload contents without doing really any work. They could just decode them, base64 decode them, and see the data held within them. So knowing that, you should never put any sensitive information, any private data within the token itself. So social security numbers, credit card numbers, really anything that you wouldn't want public and displayed in the browser, you also shouldn't put in the token itself. And so with that said, let's also take so HMAC SHA is just one of the hashing algorithms, and it's what we refer to as a symmetric algorithm. And what this means is that it uses a shared key. So the entity that is going to sign the tokens, that's going to issue tokens, is going to share the same key as the entity that's going to validate the integrity of the token. And you can imagine, this might present some issues for you if you don't want to present, if you don't want to make that key public to your backend. Another type of signing algorithm, the RSA signing algorithm and the EC DSA signing algorithms, these are asymmetric. And with asymmetric cryptographic signing algorithms, what we rely on is a private-public key pair. So you're going to have a private key that's going to sign the token, and you're going to issue public keys to entities that are going to verify the integrity of this token. So this makes it much more secure and is really the recommended way of working with JSON Web Tokens. But for demo purposes, it's always easier to show a single shared key and kind of show how it works. And then, so I mentioned that JSON Web Tokens, they're base64 URL encoded strings. They're not encrypted. But if you do need to hold very sensitive information, very sensitive data within the token itself, there is a whole set of other standards that kind of build on top of JSON Web Tokens, referred to as JavaScript object encryption, or JOSE. And JOSE is a framework intended to provide a method to securely transfer claims, such as authorization information, between parties. And JOSE is really made up of a bunch of different web standards like JSON Web Tokens, JSON Web Storage, JSON Web Encryption, JSON Web Keys. All of these kind of work together to allow you to encrypt the contents of a JSON Web Token, but that's a little bit out of the scope of this talk. And really, the use cases for JOSE are really, really limited as opposed to just JSON Web Tokens themselves. So let's see how we would use token-based authentication in the real world. Say, Thor were to come down from Asgard to celebrate the Avengers making another $1 billion, and he wanted to go out and party with the rest of the Avengers. Well, he came down, he doesn't have a driver's license, so he's not going to be able to get into the bar or club or wherever they want to celebrate. So the responsible thing for Thor to do would be to go to the DMV, fill out a bunch of paperwork, wait for 6 hours, and once they verify all his information, he's going to get a driver's license. So now that he got a driver's license issued from a trusted source, it has the right signature on it, the right hologram, he's ready to, for a night on the town. So now when he gets to the bar or club or wherever he's going, before he walks in, the security guard is going to ask to check his ID to make sure that he's of age. So he's going to, since he has it, he's going to present his driver's license. The security guard is going to run the driver's license through a little machine that checks if the hologram is on there. It has the right information. He's over the age of 18 or 21. And since he is, the security guard is going to give him the thumbs up, and he'll be able to go into the bar. Now, when he gets to the bar and wants to order a drink, the bartender again is going to ask him for his driver's license, still ensure that the driver's license is correct, is still valid, and if it is, he's going to be able to get his beer or whatever he's drinking that night. But knowing Thor, he doesn't kind of strike me as the guy who would want to go and wait for 6 hours at the DMV to get a driver's license. So he might go to a shady character, somebody from Hydra or whatever, and offer them some money to get a fake driver's license so he doesn't have to wait. So again, this shady character is going to take his money and issue him a legitimate-looking driver's license because, he has a machine that does it, but it's not going to have the right signature. It's not going to have the right hologram on it. So when Thor inevitably goes to the bar, presents his fake driver's license, the security guard is going to try to validate it, try to make sure that it is a valid driver's license. And of course, it's not going to be because it's fake. It doesn't have the right signature on it. And he's going to tell Thor to hit the road because his token is not valid. So kind of a common scenario in the real world, and that's how token-based authentication really works in the real world. Now let's tie it back to token-based authentication within our single-page applications, and this applies across any Angular, Vue, React, your own custom framework. So we have our server, again, api.avengers.com, and we have our single-page application on the front end that lives in the browser at app.avengers.com. So say a user were to come to this API, come to this application, and try to report an incident for the Avengers. Now at this point, they're not logged in, they don't have a token, but they're going to try to submit a request anyway. And the first thing our backend server is going to do is it's going to look at this request and check for the existence of a JSON Web Token. But since the user doesn't have it, they're not logged in. Oh, the endpoint was SOS. So since the user does not have a token and is not logged in, the Avengers API is going to respond with a 401 unauthorized status code or a adequate message that tells you, hey, you don't have a token, you're not logged in, you're not authorized to call this API. So now the user is going to realize the error of their ways, and they're going to hit the login endpoint at auth. They're going to pass in their username and password credentials or log in with Facebook, Twitter, single sign-on, whatever mechanism they use to log in. The backend server is going to validate the request, make sure that their set of credentials is valid, they say who they say they are, and then it's going to issue a JSON Web Token back to the single-page application. And since the JWT standard doesn't really have a standardized logo, I just use the Open for Business Japanese emoji. So I'll be using that throughout the rest of the talk, but that's just a little fun fact. So our users logged in, they were presented with a JSON Web Token, and we're going to store this token in our single-page application somehow. And we'll get to how in just a little bit. Now, when the user is ready to make a request, but now they're going to append that JSON Web Token to the request they make to the SOS endpoint. So they have the token, they have the request, and our server is going to look at the request. First thing it's always going to check for is, does the token exist? Since it does, it's going to check for the integrity of the token. It's going to check that signature and make sure that the JSON Web Token sent with the request is the one that it issued earlier. And then finally, once that is verified, it's going to check the roles and permissions or the audience claim or whatever additional mechanism to see if this request should be processed. And since the user logged in from our server, and we can assume it has all of the right payload data, all of the right claims, we're going to send back a successful response. And since this was an SOS request, we might assign an Avenger to it, and we'll put Hulk. We'll put the Hulk as assigned to this case. So that's how the token-based authentication works in SPI applications in a very simple scenario. And to show you guys what this looks like on the front end, and I'm going to use the Axios HTTP library, within, say, a Vue application to send this request. And since Keynote doesn't have syntax highlighting, I'll just do one piece at a time. So when we go to make a request, typically, say we're making a post request to that endpoint, so we would do axios.post. We would specify the URL that we're calling, so we're calling our API URL and then the endpoint SOS. And then we have our message data that we want to pass with the post request. So it's really simple. We're just saying, help, Thanos is coming. But now, to append our JSON Web Token, we're just going to modify this HTTP request that gets sent out as the third parameter. And all we're doing is modifying the headers of the request, adding an authorization header, and it's going to be in the format of bearer and then our JSON Web Token. So JSON Web Tokens are bearer tokens typically. And then finally, that's really all we need to do. And to conclude, once we make this request, we're going to process the data, and since it was successfully completed, we're going to get that message back saying the message was OK, and the Avenger assigned to this request was the Hulk. Now, let's look at a more common and a little bit more of an advanced scenario when it comes to the way we build modern architectures and kind of moving away from those monolithic applications that do everything for us. So now we have our logic server, our RESTful services at api.avengers.com. We have our app at app.avengers.com, which is a single page app. And now we want to introduce a third element to our modern infrastructure, which is an account.avengers.com domain, which is going to be our authorization server. So we're not going to want our api.avengers domain to be concerned with user authentication and making, logging the user in or out. We just want that API to process requests for help, for messaging, emails, so on and so forth. We're going to have a separate domain, a separate application that's going to be solely concerned with user authentication. So the way this works is when the user comes to our single page application, they're going to log in. And when they click the login button, they're going to provide their login credentials to this accounts.avengers.com domain. They're going to be authenticated there. We're going to verify their identity. And once they're logged in, we're going to make a callback to our app.avengers domain with that JSON Web Token. So now at this state, our api.avengers.com domain, our backend, isn't even aware that this transaction occurred, and it's not concerned with it because it doesn't care who the user is, how they get there. All it's concerned with is when we make a request to the backend that we append this JSON Web Token that we received from account.avengers.com to our backend. So once we make the request, our RESTful service is going to look for the JWT, verify its signature, verify its claims, and if all of that is correct, and if all of that looks good, we're going to send back the JSON response or XML response to our single page application to handle the presentation layer of our application.
So does that mean that API Avengers has the key to decode a token?
It does. Mm-hmm. And you guys will see in the demo how that works. Mm-hmm. So the account.avengers.com domain is going to have the private key that's going to sign the token, and the api.avengers.com domain is going to have the public key that's it's going to use to verify the token. But if you were using HS256, then you would share the same key between account and API. Sure.
It's possible to generate the JSON Web Token with the API Manager, for example. Manage the JSON Web Token for a role, for example?
You could. Yes. So you could put whatever payload data you want in the token. So you could put a series of roles and permissions within the payload itself. Does that kind of answer your question?
Is a good practice? For example, put an API Manager in the architecture of deploy? For validate a JSON Web Token, for example?
Mm-hmm. Yeah, you could do that.
But it's a good practice in the point of view the security, or it's better, for example, the JSON Web Token validate for the same application?
So in an ideal scenario, you would have you would issue JSON Web Tokens from a centralized domain, and within the payload of the token, you would specify which API it could talk to. So it would just have the permissions for that specific API. So if you had multiple different APIs that you were talking to, but a centralized authentication server, when the token is signed, you would specify the limited permissions that it has for the specific API. So in that case, it would be a good security practice to kind of limit the scope of what a valid key can do. Sure. So now we have this kind of complex scenario. And the question that I always get asked is, where do we store this JSON Web Token once it's issued from account to our app? Where do we store this token in a secure manner? Because again, remember, we don't want to have any public data, any private data, including keys, which JSON Web Tokens are, in our application. And typically, when I first started at Auth0, a couple of years ago, the common convention was to store this JSON Web Token in either local storage, session storage, or a cookie. If your token isn't too big, you can store it in a cookie. And that's really not a good practice anymore, because if your application becomes susceptible to a cross-site scripting attack or a cross-site request forgery attack, then a malicious user and a malicious actor can actually steal your JSON Web Token and use it for all sorts of malicious purposes. They can impersonate your user. They won't be able to change any of the attributes within the token themselves, but if they're able to steal a valid token and it's not expired, they could impersonate the user and place orders on their behalf or do anything that that user would be able to do. So how do we get around that without, Sure. No, absolutely.
Yes. What happened with multi-zones schedule? For example, you have a server in China, a server in other zone, for example. What happened with expiration of token?
So the expiration is held within the token itself. So the expiration date isn't on a server anywhere. And every time you make a request to the backend, your server is going to check the expiration claim. And if it's expired, the token is no longer valid. So that data is sent with the token every time it's sent to the backend. So regardless of which server it gets sent to, the expiration date is in the token itself. So now, we don't want to store the token anywhere, but we also don't want to give our users the crappy user experience of if they refresh the page or open it up in a new tab, since we don't have this token stored anywhere, they're logged out and have to log in again. That would be kind of a no-starter for many single-page applications. So let's see how we would get around this. I'll put the application back up. And the process is pretty similar. So the user still goes to our account.avengers.com domain and authenticates, provides a set of username and password credentials. Once we validated that, the first thing we're going to do is issue this JSON Web Token back to our single page application. Okay. I think I had a duplicating slide. Sorry about that. So once the user is authenticated within our single-page application, before we issue the token back to app.avengers.com, we're going to set a session identifier on just the authorization server that's going to tell us this user's logged in. Here's just a random string that's going to help you identify them. And then we're going to make a request back to our single-page application with that newly signed JSON Web Token. Now, when it comes to our single-page app, instead of storing the token in local storage or session storage, we're just going to store it in memory. So we're going to store it, like if we're using React, we might use Redux. If we're using Vue, we might store it in Vuex, or any type of state management that's in memory. So we don't want this token living in a persistent data store where it's much more susceptible to being stolen. If we can put it in memory, it'll really make it much more difficult for attackers to be able to steal the token and export it and use it against us. And then the process for talking to our backend API remains the same. We make the request with the token, the backend server verifies it, and we issue successful responses. But now, at this point, we have the session ID on account.avengers.com, and this doesn't really help our single-page application, our app.avengers.com, because if the user refreshes the page or opens it up in a new tab, they're still going to be logged out because that JSON Web Token was destroyed when the page was refreshed, since it's only stored in memory. So we need a mechanism to go to account.avengers.com, check that session ID, and if it's still a valid session, issue a new token back to our single-page application. And the good thing is we have a mechanism for that. It's called silent authentication. And let me show you how it works. Silent authentication. So we have our application, and now the user has refreshed the page. You know, they're by default, they're not logged in. But the first thing our single page app is going to do is when the page loads, is it's going to make this silent authentication request. And this is typically done in an iframe. So we'll create an iframe in the app, in our app.avengers.com domain, go to our account.avengers.com, check the existence of this session ID against a database, against our backend. If the session ID is still valid, we're going to create the new JSON Web Token, issue a new token back to our application. Again, we're going to store this new token in memory, make our requests, make our responses, handle the presentation layer. And we can do this every single time the page is refreshed or the app opens up in a new tab. We're going to make this silent auth request, make sure the user is still logged in on the account.avengers.com domain. If they are, we can successfully and safely, issue them new tokens. So at this state, yes?
So don't you have the same problem with the session ID if you have to present the session ID to the account of Avengers.com that you had before with the token?
Sure. So you don't have the problem because on your account.avengers.com domain, you can set the cookie as like an HTTP only cookie and like a secured cookie so that JavaScript doesn't have access to it. With the JSON Web Token, for it to work, you actually, if you store it in a cookie or a session, you'll have to go out and access it from JavaScript, which is what makes it susceptible. But if you can store it as an HTTP-only cookie that gets sent with, once every time the page is hit, then you don't have that problem of a malicious actor being able to steal the session identifier. And then, before I get into the demo, the other aspect of this account.avengers.com domain and having your authentication done separately from your single page app or your authorization server is that you can, or you should, only run the minimal amount of code on this domain that handles the user authentication. So, with your single page app, you might be importing a whole bunch of different NPM modules, a whole bunch of different libraries to add the functionality to your page. And it's not reasonable for any developer to go through every single app, every single library that you bring in, do a full code review and see if it's, if it has any issues, any security exploits. So if you have this account.avengers domain that's only concerned with capturing, those two form elements for the user's name and password, you're going to have a much more secure authentication experience. So now we talked about how token-based auth works in single-page applications. Yes?
So does this only work when you're using the same domain between the app and the account?
No, it doesn't. So I use the same, top-level domain as an example, but you can use, all three of these can be on totally separate domains, and that doesn't matter. You would just, in your token, specify where the token's coming from and making the callback from the authorization server to the right domain, and it would just work.
Sure. This is more of a fuzzy, understanding how my frames work.
Yeah.
Does the React likes, or the front-end store, whatever you're storing, the JWT, is that shared between the active and the actual?
So the way that works, so once you make this request within an iframe, you're going to get, you should get a response back in that iframe, and you can use the post message API to transmit the data, to transmit the token from your embedded iframe up into your single page application. And that's kind of how that communication works. And I know, when I first read this, I was like, oh man, iframes, this is 90s, this is really old school, but you could do a whole lot of really good things with iframes that are secure and make your apps a whole lot better. So I was against it at first, but once I actually got it working, it was really cool. So now I do want to show you guys, we talked a lot about theory, we had a bunch of different charts up there, and now I want to show you how this actually works in practice. So I built a little demo with using ViewJS and token-based authentication. And the question I'll probably get is, why ViewJS? And like Rebecca said in her keynote, JavaScript frameworks come and go almost daily, and what you're using today, you're probably not going to be using in a year or two down the line. And when we look at modern JavaScript frameworks, we really have libraries and more, big frameworks. So if we look at, the first end of the spectrum, the libraries, React really shines here. And React is really just a solid presentation layer for single-page applications. If you want to do routing, if you want to do HTTP requests and stuff like that, you have to bring in other libraries like Axios, like HTTP or React Router, or whatever the framework is. On the other side of the spectrum, though, we have these full-blown frameworks like Angular that handle everything for us. So they have routing built in, they have a good data model, they have its own HTTP library, and so on and so forth. So they do a lot of the groundwork for us, a lot of the heavy lifting for us. And Vue is just kind of in the middle there. It's not quite as small as a library, but it's not as exhaustive as a framework. It's just kind of in the middle, and it provides some things and does them really well, but allows the developer a lot of options on how they want to handle other aspects. So with that said, let's get into the demo. The Wi-Fi has been pretty good so far today, so hopefully we won't have too many issues. So let's greet this guy. Can you guys see that okay? Okay, sweet. So this is our back end of the application. And how many of you guys have worked with Node.js Express before? Okay, so a couple of you. So Node.js or Express is a really, really popular and big framework for building backend applications in JavaScript with Node.js. And the app that I'm building, that we're going to build today, is it's called GIF Battle. And so I do a lot of these demos, and usually, the demo you'll see is like how to create a to-do list, or how to do something simple. And I just wanted to do something a little different, where we're going to create an app called GIF Battle that's going to allow users to basically create memes out of random Giphy GIFs that we get back. And just a quick disclaimer. So we are talking to the Giphy API. We have the rating set to G, so we should get appropriate GIFs for everybody, but in case something does pop up that's inappropriate, it's out of my control, and I'll try to refresh it as quickly as possible. So once you create a GIF, and you'll have to be authenticated to do it, you're going to be able to vote, or you'll be able to put two GIFs side by side and vote on which one is better or funnier. And for this functionality, you don't have to be logged in. So you could just click vote, and it's just going to refresh. And then finally, we have our leaderboard that's going to show you, which GIFs kind of got the most likes. So if we look at our back end, we really have a couple of different endpoints. So we have a single endpoint that's going to allow us to save the GIF that we created, a post endpoint that's going to allow us to vote on which GIF we think is better, a get endpoint called battle, which is going to go into our data store and get two random GIFs for the user, and then finally the leaderboard that's going to rank those GIFs from top to bottom. And like I showed you, all of these endpoints are going to be public except the one to vote on a GIF. And the way we're going to lock that endpoint down is with this middleware here called JWT check, which is going to look for a JSON Web Token in the request. And if it doesn't have one, we're going to short circuit the request. If it does have a JSON Web Token, we're going to verify that it came from a trusted source. And then finally, if we can verify the signature and make sure that this is a trusted JSON Web Token, we're going to check and make sure that we have the correct audience. And in my example here, the audience is GIF Battle, and the issuer that we're expecting, Auth0 to issue the token. And just to show you that this works, so we have this random endpoint that's going to give us a random GIF. And right now, it's unsecured. It's public. So if I were to hit this endpoint, So if I were to hit this random endpoint, I get a JSON response back with a random GIF, and I can hover over it, and I do. And if I refresh the page, I should get a new GIF, and I do. But if I were to add that JSON Web Token check middleware, or if I were to lock down the random endpoint to require the user to be logged in to get a GIF, and I just did that here by just passing the JWT check function. If I were to access this endpoint now, instead of getting a random GIF, I'm going to get an unauthorized error saying that no authorization token was found. And I'll just remove that for now because we have this functionality here when we go to save a GIF. So let's go into our application. Does someone have a question? Or, oh, no. So if we look at the code of our application, let me put it up here, and I'll zoom in. OK, so my application is truly a single-page app because everything is in the index. How many of you guys have worked with ViewJS before? How about Angular 1.x? OK, so ViewJS is really, really similar to Angular 1.x. And really, I'm not going to go over too much of how Vue works. But basically, like if you work with Angular, ngIf, in the Angular world is v-if. In the Vue world, you have click methods, click functions. The data interpolation is pretty much the same. So it's very similar to how Angular 1.x works. But our Vue application lives entirely here, starting on line 128, where we instantiate Vue and pass in some data. So by default, when we load the app, we're going to have our API URL and a couple of properties to get our data, our random GIF, our leaderboard, so on and so forth. And then in memory, we're going to be storing the access token, JSON Web Token that's going to talk to our backend, and an ID token that's going to hold our user information. And once our application is loaded, once it's created, we're going to run this handle authentication method every single time. And what this method does is it looks at the query parameters of our app to see if this is a callback function, if there's a JSON Web Token in the browser bar. And if there is, we're going to take it and store it in memory. And typically, you wouldn't run this handle auth function every single time your page reloaded. You would just do this in your callback method, on the callback route of your application. But since we don't have routing in this app, we're just going to do it every single time. And then finally, we have a set of methods that go out, using the Axios HTTP client library and hit our endpoint, get the user data, and then display it. So that's all of these guys. And then finally, at the bottom here, we have our login, logout, and refresh session methods. And these methods, they come from a service that I wrote here called using Auth0. So we're going to use Auth0 just as our authorization server. And since Auth0 is built entirely on open standards, everything you learn here will be applicable to your applications whether or not you're using Auth0. But we're just going to use it so we don't have to build our own login form and do all of that fun stuff. We're just going to kind of speed up the process of issuing the token. So we have a number of functions here. The login, which is going to go to that Auth0 domain to log the user in. The handle authentication method, which again is going to check for the tokens. And the check session method, which is going to allow us to do that silent authentication, which I'll show you. So let's go ahead and see how this works. So now, here I'll refresh the page again. And right now, I get a message in my single-page app saying that I'm not logged in, so I should log in to be able to create GIFs. So I'll click Login to create, and it redirected me to autobot.auth0.com. So right now, I don't have to be on that same domain like you were asking earlier. I could be on a different domain that'll handle my authentication and authorization. So I just see the login screen here. There's no other functionality other than to log in or create an account. So I'll just log in with an account that I already have. And now I get the message that I can create a GIF. I'm authenticated. I'm logged in. And the login button has turned into a logout button, and I ideally should be able to go ahead and create GIFs now, right? Let's see if that's going to work. So I'll open up the developer tools as well, just so you guys can see what's going on. But let's just say I wanted to, add some text here and create the GIF. So I, added some text, clicked the Create a GIF button, which made a request to my backend API, but I got an error saying request failed with the status code 401, and basically this request failed. Any idea why? No. So the request failed because even though I am authenticated, I have a JSON Web Token, I didn't attach it, I didn't append it to my request. So if I look here, if I look at the request headers that I sent with this request, I have, accept encoding, blah, 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 but I don't have the JSON Web Token. So my backend server, once it gets the request, it checks for a token and says, hey, you don't have a token, and it just does that unauthorized token response. So let's go back into our code here, and in our index, and actually append a token once we have it. So here, when we click on Save GIF, we're going to pass in a third parameter, and we're going to add some headers to it, the authorization header in specific, and it's going to be a bearer token, and then we do app.access token. So we get this access token from our in-memory data store here from our Vue application. So now that we have that, let's go back to our app. And to have this new code work, I'll have to refresh the page. But when I do that, I kind of get that crappy experience where I'm not logged in anymore. And I'm not logged in because I refreshed the page, my token was in memory, I didn't make a silent request to my backend API, so now I would have to go and log in again. And I'll do that. So I'll click the login button, and I'll log in with the same account again, and now I'm logged in and should be able to save a GIF. So let's see if that's going to work this time, since we are storing the token now and passing it with our request. So demo time. Now, when we click Create GIF, our request went through, we didn't get an error, and if I go and inspect the network tab, I can see that the message was successful, so our request went through successfully. And if we look at the headers, we can see that in our request headers, we now have this authorization request in the format of bearer and then the length of our token, basically the entirety of our token. And we can actually show you what this token looks like or what data it has within it. I'll just copy it and I'll quickly decode it using JWT.io, which is just a utility for working with and decoding tokens. So basically, I just pasted my token in here, and it tells me this is a JSON Web Token. The algorithm used was RS-256, and the payload, we have the issuer, we have the subject, we have the audience, so which APIs it's meant for, and in my case, it was GIF Battle, and then when the token was issued, when it's going to expire, and then a couple of other pieces of information. So since I have this token, I can debug it, but if somebody were able to get a hold of it, they could basically impersonate my user. So let's go back into the app, and to conclude, let's look at how the refresh token functionality works. I'll just refresh the page, which is going to kill my session again, and now I'm seeing, I have to log in, and this would be really annoying to do every single time I refresh the page or open it up in a new tab, and I can honestly say for a fact that I've never seen anybody have a refresh token button that would go out and get you a new token either. But for demo purposes, I added it here just to show you how it works. So before I click it, I'll open up Developer Tools, and let's open up the Network tab, and I'll click Refresh Token. So you can see that now I am, since I clicked that, I'm logged in. I get the Create GIF button again. The login turned to log out. And this is that iframe request that I made. So I went to that auth0 domain. I passed in my user information that was specified in that auth0.js, and I got a response back in that iframe via the post message API. So basically, web message request. I got the authorization response, I got the token, I got all of that data, which was then passed into my single page app and saved the token again, processed that handle authentication method, and allowed my user to log in. Now, this would be really annoying to every time I refresh to have to click refresh token to get my user experience back on track. But since we are using ViewJS here, we can actually run this piece of code every time our app is loaded in this created lifecycle hook. So if I were to do that, I could do window.authService check session. I'll save. And now when I go back to my application and I do a hard refresh, now it's going to do this automatically. So every time I refresh my single page app, it's going to silently make that request. That's why we call it silent authentication. It's not transparent to the user at all, or it's fully transparent to the user, but it goes to the authorization server, checks whether the user is logged in or not. If they are, issues a new token and says the user's logged in. And again, every time I refresh, I'll get that experience. And just to show you that this is actually happening and this call is being made, let me go back and hit this domain just in my regular tab. I'm not going to get any data because it's sent via JavaScript, so there's nothing rendered on the page. But what I want to look at on my authorization domain is its cookies, right? So here I have this auth0 cookie set, which is basically my session identifier for that specific user. And with this session ID, with this session cookie, I can go ahead and call that refresh method anytime I want to get a new JSON Web Token. But what's going to happen if I were to delete all of these cookies and now try to do that check session, refresh the page or click the check session button? Let's find out. So now, when I go to refresh my page, I'm actually going to get that error, or a different error here, saying that the login is required because now my user, the page reloaded. I called that check session method. It went to the authorization server and said, hey, is this user still logged in? Do they have a session ID? And since we deleted it, they do not have a session ID, so we're not going to get a new JSON Web Token back. We're going to assume this user's logged out. They don't have a token, they don't have a session, so they don't get a token. And to get a token back, they're going to have to go ahead and actually log in. And since we deleted all the cookies, we're going to have to actually provide our credentials to be able to successfully log back into our application and create gifts, vote on gifts, get the leaderboard, and all of that good stuff. So that's really the demo that I had for you guys. Do you have any questions about the demo or how any of it works? I'll go you first, and then we'll go back and forth.
Am I correct in thinking all the claims in the JWT are accessible from the browser?
No. So they shouldn't be. So the token that you store in your single page application, you can decode it and you can work with the claims in the browser, but it's not recommended, right?
Well, would stop a hostile add-on from doing so.
So if you store the token in memory, it would be much harder for a malicious actor to gain access to the token in the first place. And that's why you shouldn't put private or secure data in the token itself. You should just put the claims that'll help your backend kind of understand what the request is trying to do. Does that kind of make sense? So basically, like right now we have the access token, and let me just show you this. This might make it a little clearer. So the access token that we're using to talk to our backend API has a limited number of claims that help us understand who the request is for and what the user should be able to do with this token. We have another token here called the ID token, and this one we actually can and should decode in the front end. And this token contains our user-specific information that we'd want to display on the page. So if I look at the payload, or if I look at the data of that token, actually, did I not store anything there? Well, I can actually look at the ID token payload here, and the ID token you should decode because that's what contains user information. And actually, let me show you a better demo here because this doesn't give you all that much. So when we request our tokens, here I'm just requesting OpenID, so that doesn't send you much. But if I were to request the user's profile and their email information, for example, once we get a new token, let's go back into the app. And I will log in with my account. And now, my app is asking for additional data about my user, their profile and their email. So I'll go ahead and accept that. And now, if I look at the payload of the token, I have the user's email, their picture, their avatar, their, I guess I don't have a first name and last name set here. But with the ID token, you should decrypt that one in your single page app to get data that you want from the authorization server to display within your app.
It's not actually decrypting, it's just basically for a token.
Yep, exactly.
So you're saying that the data that's passed to the JWT is not actually secure.
It's not secure. That's
It's just signed.
Yep.
And that you should control what information is included there because it may be accessible to third parties.
Exactly.
So where does OAuth fit into the picture?
So OAuth is basically so the OAuth standard is really built for federating identity between different services, right? So OpenID or OAuth, it uses JSON Web Tokens to transmit user data. So when you go to an authorization server, or you do a social connection login with, say, Facebook or GitHub or Google or whatever, once you are logged in and authenticated and you grant access to a specific application, depending on the data you requested from Google or Facebook, it's going to put that data in the JSON Web Token, sign it, and send it back to your application. So OAuth is just kind of built on top of JSON Web Tokens, and it kind of relies on them for the data interchange. Yes?
Yeah, I was hoping you could kind of go over the implementation and sign authorization request and background.
So the code implementation is, I can show you how it works. So right now I'm using the Auth0 service. So this check session method doesn't really tell you all that much how it works. But if I go and look at the, I think it's called Auth0.js, GitHub. So to show you how that code works, so this Auth0.js library, this SDK that I was using in the app, it is fully public. It's open source, so anybody can look and basically copy the implementation. So to show you how it works, let's go into the source. I think it's WebAuth, silent authentication handler. So basically, this is these 90 lines of code are how that implementation works. So there might be a couple of different attributes here that are specific to the Auth0 implementation. But generally, if you look at this piece of code, it'll tell you how it works, how to create the iframe, what data to pass to it to your authorization server, and depending on what auth server you're using, it's going to vary. So I could share this link with you, or if you just Google auth0.js GitHub, you'll be able to see the code. And then somebody else had a question.
Yeah, I was trying to trace the. I was trying to trace the secure retrieval of the token on the refresh, because you mentioned not to store the JOT because then it could be used.
Right.
But then you stored a session ID, which could then just be used to obtain a JOT anyway. I feel like I missed something.
Right. So basically, what happens is. you have the session ID that lives on the account.my app domain. And this session ID is a HTTP only cookie, right? So JavaScript doesn't have access to it. Nothing has access to the session ID except your backend. So whenever you hit that endpoint, the cookie gets sent to the backend, verified, and then a new token is issued. And then when you get your token in your single page application, you would store it in memory, like in a Redux store, or just here in like data attribute in a View app. And that way, it makes it really difficult for a malicious actor to be able to steal the token by, having a cross-site scripting attack, or, if they have full access to your app, they're going to be able to do some bad stuff. But doing it this way, where you're not storing the token in local storage, persisting it over the long run, it's going to make your app a lot safer, a lot more secure.
So I gotta ask, why don't you just get a new token every time so it's the same session?
You could, but when you're building a single page app, you're making a whole lot of requests to your backend, and if you wanted to go and hit the auth server every single time to get a new token, you could do that. It just might be a scalability issue if you're doing like millions of requests every so often, because these tokens do have to be signed. So the hashing algorithm, does take some resources to sign it. And yes.
JWT is a good practice, for example, for expose RESTful web service. I don't know, for example, first you, in the flow of the application, first you pay the JWT to the server, and then you validate JWT and each request for a RESTful web service, for example. Mm-hmm. What happened? Is a good practice in that case?
Yes. So whenever you get the token, you would send it back with every request to your API server, and you would validate it every single time, because something might have changed, or if a malicious actor were to be able to get a hold of the token, maybe they try to change some attributes within it, which would invalidate the signature. So if you don't verify the integrity of the token, they can kind of do bad stuff. So yeah, every time you send it to your RESTful service, and whether that's a REST API or a GraphQL API, or whatever messaging system you're using to transfer your requests, you should send a token with it and verify the token every time.
All right, first really dumb question. Are JOT tokens similar to, or are they a type of OAuth token? What's the relationship between OAuth and?
Yeah. So OAuth uses JOTs basically in there. Whenever you log in and you get a response back, you'll get a JSON Web Token with OpenID and OAuth payload claims data. Yes.
When you use OAuth, who generate the token? The server or the OAuth server?
It would be so the way that works. So if you were using OAuth, for example, say your user came to your authorization server and they clicked log in with Facebook, right? So you would go to Facebook, log in with your Facebook credentials, and you would get that little message saying, hey, my app is trying to, you're trying to log in with this app, it's requesting this data. When you click approve on that, a callback gets sent to your authorization server with the user information, with the JSON Web Token that has payload data about the user. Now, your authorization server would take this JSON Web Token, get its data, and create its own token with different, it might be the same data, but it would create and sign its own token that would be sent back to your application. Cool. So I think I had a couple more slides just to close this out, just to summarize. So to summarize, single-page application security is mainly concerned with the authorization use case. You can't really have a secure single-page application. You can't have private keys. You can't have secrets in your public app without somebody being able to get a hold of it, which kind of defeats the purpose. JSON Web Tokens are really excellent for securing single-page applications in this regard. And then there are many excellent HTTP libraries that make it really easy to work with JSON Web Tokens and your single page apps. So I used Axios in my example and demo, but you can use, HTTP XML requests, you could use jQuery, you can use the Fetch API. With Angular, they have the HTTP client library, there's so many libraries out there that make it really easy to work with HTTP requests and append these tokens. Likewise, there are a lot of JSON Web Token implementations. We at Auth0 have like 600 something open source libraries for different languages, different frameworks that'll help you sign and verify the integrity of these tokens. So, whether you're building a .NET app or a Go app or a PHP app, there's a library out there that'll help you work with JSON Web Tokens.
So what library do you recommend for using for JWT tokens?
So if you're on the front end, like if you're using it in your SPA application, like Axios is my go-to for most things. But really anyone works, whichever one you're kind of familiar with and have worked with in the past, it'll more than likely work. And then finally, a security guard probably couldn't stop Thor from getting into a bar, but your server can absolutely refuse requests that don't have valid JSON Web Tokens and the right claims data within them. And then some additional resources. If you guys are interested in learning more, because there's so much more to JSON Web Tokens, how they work, I have a couple of items to take away. So if you're interested in just kind of getting this overview of JSON Web Tokens, jwt.io is a really good website. I kind of showed it in the demo where you can decrypt a token, see what payload claims data is within it. So if you were trying to debug a token or just trying to learn how it works, the size differences, jwt.io is great for that. And on that side, we also have a whole bunch of the open source libraries that either we contribute to or we maintain for different languages and frameworks and the different features they support. If you're interested in learning more about the different JSON Web Token signing algorithms, why use RS-256 over HS-256, what the implications are, and so on and so forth, I have this bit.ly link at jwt-alg that's going to give you a whole lot of information. And then finally, if you really want to get down and dirty into JSON Web Tokens and learn all of the ins and outs, there's a free handbook that my colleague Sebastian wrote called the JSON Web Token Handbook. It is absolutely free. It's a PDF. You can download it, read it on your own time. And he updates it like every month with new findings, with new information. So you can find that one at bit.ly jwt-book. And thank you. That is all I had for this talk.
Just wondering if it's common for folks to implement a token revocation list, or it's not worth the expense or runtime cost?
So it's definitely a good idea to have a token blacklist. And so the reason you would build a token blacklist is once you issue a JSON Web Token with a specific signature, and that signature is valid, that token is, you can kind of revoke it. Or, ideally you wouldn't be able to revoke it. It's going to be valid until that expiration time passes. But say you were to, run a company and you have a new employee start and he logs into your systems, you issue them a JSON Web Token, and a few hours later, you fired them because, they were a bad employee or they did something bad. But this token that you issued them doesn't expire for another 2 days. In that case, they would still have access to your entire, backend to your systems because they technically have a valid JSON Web Token. Now, you could, change the signing key, but that would invalidate all of the valid JSON Web Tokens that are out there, so that would inconvenience all of your users. So what you can do is build a token blacklist, which would be a lot shorter than storing sessions for every single user that logs in. Where once the token is verified and its integrity is still intact, you would make a call to a database and say, hey, is this token still valid or is it on the blacklist? And since this blacklist is going to be much shorter, it's going to be faster to process, faster to to check the integrity, and if it's not on the blacklist, you just process the request. If it is, you send a unsuccessful response. So yeah, I mean, blacklists are commonplace with JSON Web Tokens. Yes?
So when it comes to claims and roles, based off that question, if
Uh-huh.
a user, or if you were to try to add roles to a user after they've already been given, granted a token,
Mhm.
what is the paradigm for say, tell them saying that, hey, I need a new set token for these roles or
Right.
claims?
So to do that, basically you could do that when the silent authentication request kicks in, because once you do that, you're going to check that session ID against the database to see if the user's still logged in. You could write very simple logic that'll also check if the user roles and permissions have changed, and if so, you just sign that new token with the new roles and permissions. Yep. Yes.
Under what situations would you consider using encrypted jobs?
So you would use encrypted jobs if you had sensitive data and sensitive information that you did want to pass, between the client and server, and these tokens were going to live in your browser. So, one use case might be if you're doing like a wire transfer, right? If you're sending money over and you want to have those user accounts in the JSON Web Token. So you want to send it over HTTP. You don't want to send it in just like an empty post request. So that might be a use case where you use JSON Web Encryption to encrypt that data. So once it's sent over the wire, the server can process it, get the encrypted information and then process it. So the use cases for JSON Web Encryption, they're kind of limited in scope. They're not commonly used, but there are there's obviously use cases. Otherwise, we wouldn't have the standard. And yeah, I think that's a wrap. Thank you, guys.